Table salt and aluminum foil. Two of the most ordinary items sitting in your kitchen drawer right now, but when combined in just the right way, they produce real, measurable heat. No flame, no electricity, just an unstoppable chemical reaction. So, if generating heat is this simple and uses materials that cost pennies, why is it almost never discussed as a mainstream survival tactic? The answer is hiding behind three brutal truths. First, you cannot patent this reaction. Second, the energy industry has spent millions of dollars making sure you never try it. And third, as of today, 23 states have quietly passed laws making this exact survival trick completely illegal. Aluminum was not always a throwaway item. In the middle of the 19th century, a single ounce of aluminum could cost nearly $5. That was more than triple the price of silver at the time. Jewelers and industrialists treated it as a status symbol, a gleaming rarity reserved for the elite. Victorian advertisements compared its shine to silver-plated jewelry. In some circles, a sheet of aluminum was considered a more impressive gift than gold. That status did not last. In 1886, a new industrial method shattered the old market. For the first time, electricity could rip aluminum from its ore cheaply and in bulk. The price collapsed almost overnight, dropping from luxury levels to just 30 cents per kilogram by 1890. What had once been locked in the cabinets of the wealthy now rolled off industrial lines in massive sheets, destined for every kitchen and factory. By the 1920s, it was everywhere. Wrapping sandwiches, lining ovens, sealing up the remains of dinner. Surrounded by crumpled sheets in a kitchen drawer, it is easy to forget just how much energy and ingenuity it once took to make something so ordinary. The transformation from a metal of kings to a disposable commodity hides a deeper story. Even as foil became cheap, the chemical energy locked inside every sheet never disappeared. It simply waited, sealed behind a barrier so thin it is practically invisible, but strong enough to keep the metal's true potential out of sight. Every sheet of aluminum foil comes with a lock. The moment the metal leaves the rolling mill, it is instantly sealed behind a barrier just a few nanometers thick, a skin of aluminum oxide. This is not a coating added by the factory. It is a natural reaction with air. It is so fast and so reliable that even a razor-thin layer can shut down the metal hunger for oxygen and water. On the scale of atoms, that is only about 15 layers deep, far thinner than a human fingerprint. Yet it is strong enough to keep the foil from corroding in a steamy oven. The real trick of the everyday safety of aluminum is this self-healing film. Scratch the surface, and the oxide reforms in microseconds. That is why foil can wrap leftovers and survive a splash of lemon juice without falling apart. The energy trapped in the pure metal underneath stays locked away, inert as long as the oxide skin remains unbroken. This barrier is the reason why a ball of kitchen foil will not heat up or burst into flame when dropped in water. The oxide blocks almost every chemical attack, keeping the raw reactive power out of reach. For all the talk of free heat, the real story starts with the search for something simple enough to pick that microscopic lock. Salt. So ordinary, it disappears into your food. It turns out to be the exact key needed to unlock the hidden energy of aluminum. The magic starts at the atomic level. Table salt dissolves in water, flooding the surface of the crumpled foil with chloride ions. These ions are relentless. They worm their way into the invisible oxide skin, attacking the barrier that normally keeps the metal dormant. The moment a chloride ion breaks through, it opens a microscopic pit, exposing the raw aluminum directly to the water. The reaction is immediate. Hydrogen bubbles fizz up from the foil. The temperature of the liquid climbs fast. In a typical demonstration, a 2-inch square of foil in salty water can push the temperature up by 10 degrees Celsius in less than half a minute. This is not a trick of perception. Calorimetry confirms that a single gram of aluminum can release about 15 kilojoules of heat. That is enough to noticeably warm a mug of water in freezing conditions. Yet the reaction is finite. The aluminum is consumed. The oxide reforms. The system shuts itself down. What looks like endless heat is in reality a one-way ticket. A burst of chemical energy liberated by a simple unbranded trigger. The bubbling, the warmth, even the faint metallic smell, all point to a real, measurable transformation. It is not perpetual motion. It is a flash of power from materials so common they barely register as technology. The chemistry is undeniable, but the story it tells is even more potent. Because sometimes the most disruptive unlock is not a new invention at all. It is a household staple, quietly breaking the rules of who gets to control energy. Nothing in the kitchen drawer feels more like a loophole than heat with no visible fuel. The idea that salt and foil can be combined to make warmth cuts against every expectation. There is no flame, no plug, no branded canister, just a fizz, a rise in temperature, and the unsettling sense that something big is happening under the surface. For most people, heat means fuel. Propane tanks, natural gas lines, stacks of firewood. Each of those comes with a price and a supplier. A meter spinning on the side of your house. A monthly bill you cannot negotiate. But when a crumpled ball of foil in salty water can generate heat, the rules feel rewritten. The promise of this reaction is not about infinite energy. It is about the thrill of bypassing the gatekeepers, finding a hidden backdoor to comfort and survival. That feeling of independence, of outsmarting the system, makes the chemistry more than just a science experiment. It turns a kitchen reaction into a quiet declaration of autonomy. And for industries built on selling heat by the refill, that is a threat they cannot see, but absolutely cannot ignore. Patent examiners have seen it all. Foil, salt, water. But when the paperwork lands on their desk, there is nothing new to grant. Every attempt to claim the reaction itself runs into the same dead end. The chemistry is public domain. The ingredients are household staples. And the process is as old as the corrosion tables in a freshman textbook. The only patents that survive are for containers or clever packaging, not for the reaction that actually makes the heat. One examiner, writing in a 2018 office action, called the aluminum salt system a textbook example of prior art. That means no company can lock up the rights, no matter how many diagrams or flowcharts they submit. For trade groups built on selling fuel, this is a nightmare scenario. Over the last decade, propane and natural gas lobbies have poured more than $8 million into state-level campaigns. Not to patent the chemistry, but to shape the rules around it. Their filings do not mention foil and salt by name, but they target unregistered metal fuel heaters and push for language that keeps do-it-yourself solutions off the market. When a reaction cannot be patented, the only lever left is policy, and the push to control the narrative moves from the lab to the legislature. In 23 states, the question of homemade heat has become a matter for lawmakers and fire marshals. Not just chemistry sets. The statutes do not mention salt and foil by name, but the language is unmistakable. Bans on unapproved chemical heating devices, prohibitions on metal fuel reactions, and civil penalties for any device that generates heat by combining aluminum with halide salts, California Health and Safety Code, New York fire regulations, and Texas hazardous device statutes all draw their lines around the same risk. Hydrogen gas. Invisible but explosive. Released in kitchens and garages by reactions no one can patent or control. The enforcement record is no longer theoretical. Since 2022, fire departments from Colorado to Tennessee have cited dozens of cases, including recalls and fines, and even a handful of criminal prosecutions when do-it-yourself heaters failed safety tests or triggered small explosions. In a 2024 hearing, a county fire marshal put it bluntly, "It is not the chemistry that scares us. It is the idea that anyone can do it anywhere with things they already have." The bans are a patchwork, but their effect is clear. What began as a loophole with heat from leftovers and salt now sits behind a wall of legal language, sealed off by the same authorities who once recommended aluminum foil for emergency kits. Curiosity has become a liability in the eyes of the law. The freedom promised by kitchen chemistry is now a fire hazard, and the simplest triggers are the ones most likely to be forbidden. Today the threat is not in salt or foil. It is in the idea that something this basic could sidestep entire industries. That is why the story keeps spreading. Not as a simple chemistry trick, but as a quiet rebellion. The true power of this reaction is not about heating a room forever. It is about waking up to how the system actually operates. When a survival loophole is discovered, the first reaction of the establishment is not to share it, but to outlaw it. The heat from aluminum and salt will eventually run out. But the desire for self-reliance never does. Sometimes the simplest trigger is the hardest force to control. What do you think about these new laws? Let me know your thoughts down in the comments. And make sure you are ready for our next deep dive, where we expose another everyday item sitting in your garage right now that regulators are quietly trying to ban next. Stay alert,